Okay. Oh my goodness. This wasn't showing last time. Yay. Oh, it says it's recording. We don't want that though. Not yet, at least. Okay, y'all. So this is 4.2, still logarithmic functions. More specifically, like as far as your homework's concerned, it's part 2. Okay. So I love these so far. Logarithmic functions. Part 2. Okay, so what I'm going to show y'all are these 2 different, they're called special logs. We actually are going to have a common log and a natural log. So the first one that I'm going to show you is a common log. And if you look on your calculator, right, like there's the math button, 2, 3 buttons under it, it says log, L-O-G. Okay, if you actually push that button, you'll notice that it opens up a parenthesis, right? So like we're going to solve some of these. I'm going to show you like if it explicitly states without a calculator, this is the work required, right? But then there's going to be some problems that you run into that don't tell you to solve without one. So of course you'd use it, or you kind of notice like, I can't even solve this by hand. I have to use a calculator, right? If it's an actual log problem, what you do is you just hit your log button. It's going to open up right here, and then you'll be able to enter something in and get an answer. The second problem, we'll use our calculator. The first one, I'm going to show you by hand. So common log, like I said, it's usually you could see it written as log, and then for our base, it's a 10. And then, you know, you have something written there, whatever it may be. It could be a number of different things, right? So y'all, this right here, like I said, that's a base 10. Now, as far as us just writing it, or I'm in the notes, we could just say that it's written as log, and then let's just say x. If you see this, like all the other problems that we had, y'all didn't, it had a base, right? Some of them were like abstract. It was a B, it was an X, it was an A, it was a 2, whatever it may have been, there was an actual base written. If you don't see a base written, it is implied that it's log base 10, okay? But if I can use just log and not have to always write 10, like of course, I'm gonna choose to do that. So let's do this first problem. Say, what they give me is log, and then it's of 1,000. So you notice here, they didn't write the 10, right? And it tells me like I'm evaluating this or I'm solving this. If it was to say to solve this without a calculator, the way you would do this is you'd want to turn it into exponential form like we did before, where this is our B, right? Base, answer, exponent. This is our B. This was the answer. This is the exponent. So for exponential form, it's our B's this base, which is 10, right? It's not written, so it's implied that it's 10. So our base is 10, and this would be saying 10 to the what power equals, in logarithmic form, this is our A, this is our answer. So equals 1,000. That's what this is saying. By hand, this is the work that I would be looking for. If you just put the answer, you get very small, like nothing points, because it said, show me the work, basically, right? So, I mean, this would just be 3, right? Whenever you raise 10 to a power, whatever power you raise it to, y'all, just a shortcut, that's how many zeros you get. If you raise 10 to the 4th, you get 4 zeros. 10 to the 5th, you get 5 zeros, okay? So since I know it's 10 to the what is 1,000, you could start doing 10 to the 2nd, 10 to, you know what I mean, to see. But my 3 being my exponent, that gives me a total of 3 zeros after the 1. So the answer would be 3. And that's seeing it in this form and being told like without a calculator, right? So for this example, say we have log, there's not a base written. So I'm implying log base 10, and then I have a 5 equals, I don't know yet, right? My answer is going to go here. This is a base 10. So this is saying 10 to the what power equals 5. If you do try to go through some of the steps that we learned before with the exponent rules, you're going to notice that you don't ever really get here, right? Because in order for it to have gotten smaller, I would have probably had to have taken a root, right? I took like a square root of 25, I got 5. Took a cube root of 27, I got 3. If you take the square root of 10, that's not a perfect square. I'm not getting a 5. Cubed root, well, I'm definitely not getting to 5. You see what I'm saying? You kind of go through a process of elimination. You notice this isn't going to work. I'm telling you now, I wouldn't give you a problem like this and tell you to do it without a calculator. This would be one of the ones that just said evaluate. So we literally can use our calculator here because we notice that we don't have another option. So I already had my log typed in here from showing it to you previously. This is log because nothing is written. It's implied. It's base 10. You just type the letter 5. You can close it with another parenthesis, but you don't have to. When you hit enter, you'll get 0.6989700. The homework and on an exam, it would say round to the nearest whatever, right? So for this answer, I think I rounded to like the 5th, but I want to be able to write it here. So I'm just going to round it to the 3rd decimal, which would be 0.699.699. So of course, if you use your calculator, just an answer is okay. It didn't say show your work. It didn't say without a calculator. So with your calculator, you wouldn't have to do this right here. I was just trying to explain to y'all any of those like roots as an exponent, like they wouldn't have worked, right? Okay, so this is also very important, especially going towards 4.4. If you have log, there's nothing written, so we're implying base 10. And I just noticed I can probably zoom in a little bit here. And then it says -3 equals. So this would be asking what would be our 10, right? What raised to this power equals 3. So my base is 10. Raised to what power? And that's a -3 actually, equals -3. Anything raised to any power is never going to give you a negative answer. So if you kind of get confused here, like, hold on, let me use my calculator, right? So I just type log and then not the -3, but the -3, okay? -3 is already going to give you an error, but it's like specific here. This is a -3, enter. I get an error, okay? What this means is that we cannot take the log of a negative number. That's the important fact to take away from that. Okay, so what you get here is error. And then let's call that star, and let's put a star right here because that's too small of a box to write error. But same thing, error, error. And then you could go ahead and do a note here that just says can't take log of negative number. Of course, y'all can write out more words. It's easier in pencil. So that's one of our special logs. Another special log, I'm just going to go and change papers, is a natural log. So if you see the whole word log and there's no base, we're implying it's 10, that's common. Okay, that's the common log. If we have our natural log, okay, so this is log, and our little base is E. That's that Euler's number, right? That one that we had talked about. And then you would have something written right here. So this is actually base, why did I do best? Base E. Sorry, that's a base, y'all. And this is written as, sometimes it'll look like it's cursive. After a while, I may just write it in print. So you're either going to have LN, And then, we'll have something there. Or you'll see me just do ln, and then something would be right here. So it's either or, okay? Now, the way that we're actually going to evaluate these, let's do this problem right here so I can show you. And again, there's some, not all of these, with all of these problems, obviously, you can't just enter all of them into the calculator, right? But there's a lot of them you can, but I'm kind of showing you if you forgot your calculator or you forgot how to use it, you could use the properties that we learned last time. Like you can do two different things, right? So if we have ln, and then we have e raised to the 5th power. Okay, so what we can do, if it tells us to, it's like a cursive ln, and then e, and then that's like an exponent. E is also the base. Yeah, this is ln of e to the 5th, though. Now, in this form, Haley, with the log, we have log base e, and so that's what I'm going to do is show you, like, if it says solve this without a calculator, I'm not expecting just an answer, right? I'm wanting to see the work. Solving this without a calculator, I started doing arrows. I don't really know why, but solving this without a calculator, what we do is you take log base e, and then this, after the natural log, right, just that e raised to the 5th power, that's going to get written right here, e to the 5th power. That was that property that we learned on Monday, where I told you that if you have a base, and then this is usually our a, right, but then it's being raised to a exponent, that the answer is just that exponent. If y'all go back and you look, you'll see that that we had done a couple of examples like this, okay? Putting it in this form allowed me to see this, which I could just throw it into e. And remember, this is because e raised to the 5th power equals e raised to the 5th power, right? I did all those little notes on Monday. Or if it didn't say do without a calculator, y'all, I did it earlier when I was doing this lesson plan. If you look right here, okay, natural log is this ln button, so it's under the log, right? So I touched ln, it opens up that set of parentheses. I did second, and then my e right here, and then I did the caret, the little upside down V right above the division. That lifts like your, what's it called? It's like a cursor up into the exponent. And then I did the number 5, I hit enter, and then look, I get 5, okay? So there's a, she didn't tell me to do it without 1, and then there's a, I can do it with 1, okay? You got 2 different options there. Let's do a couple more of these. So for this second one, say we have ln, and then it's the number 1. Y'all, if you do the ln, oh, let me get out of here, second mode. If you do ln and you type in the number 1, I'm going to get 0, okay? Because my calculator can solve a lot of these within like a matter of seconds. That's why the majority of problems in algebra will say without a calculator or show all of your work, right? It's like, did you learn what you were taught? But you can enter these into your calculator as well. If it told me to evaluate this using this same process right here, I would take log base e of, it's just this, just the 1, equals, this is what I'm looking for, right? Well, if I have something in log form, we could turn it into exponential form, unless you start to remember this is saying e to the what power equals this. Remember, base, exponent, answer. Base, exponent, answer. So e raised to the what power equals 1. It's just 0. Anything raised to the 0 power equals 1. But if you wanted to go ahead and put an exponential form, this is our b, this is our exponent, this is our 1. I see here, in order to get the answer 1, and what I did previously was raise something to a power, that power had to be 0, right? Those are those exponent rules. So this would be 0, that would be 0. Okay. Wondering why I didn't put this one as the 4th one, but I don't know why. Okay, say we have ln of 5. And I'm going to go ahead and attempt this, solving it by hand. This is actually one that ends up needing a calculator, but that way you can see it. I would take log base e of 5 equals, I don't know. Let me turn this into the exponential form. This is bxa, right? bxa. So my b is e. My x is I don't know. And then I have a 5 here. If you start trying to input things, you're going to learn that no matter what you do or what you think, it's not really working. So this would be one that you would use the calculator for. And there's no reason to use your log here. You would just type ln of 5 equals. You get 1.6009, okay? So 1.60, actually it would be 61. So 1.61. I said, I wonder why I didn't put that as number 4, because that one, it's like, we determined we had to use a calculator. This one, we don't have to. Okay, y'all, let's do ln of e. Using it like without a calculator, solving it by hand, I know that what I do with my natural log is I take the log base e of what it says here, which is e. This is what I'm trying to solve. If you've already gotten it down, this is saying e raised to what power is e? E to the first power would be e. But if you haven't gotten it down yet, put it into exponential form. This is my b, which is e. This is my x, which I'm trying to find out. And then the answer right here is this e. The only way I'm going to raise something to an exponent and get that same something as an answer is if my exponent is 1. Similarly, with the only way I'm going to get 1 as an answer is if my exponent is 0. Okay? Does that make sense, y'all? Yeah? Okay, so it's weird. I followed the way the homework did it. So they did problems like this. You'll see E represented. Then they do, I don't remember there being many, maybe 2 or 3 graphing problems. And then they go into evaluate these without a calculator. So I just kind of did them in that same order. It's like, why not do all of the evaluations first and then the graphing? I'm going to show you how to graph these. I think the 2 that are on there use some transformations. I'm using old notes from Laura Bean's class, and this one's just a graphing, but I'm going to tell you the work put into this. It's really just find your inverse, and then on the homework, you graph it, or you just know where to, I'll tell you. I just didn't do one with the transformations. I want y'all to know how to do the transformations at home, okay? So graphing these logarithmic functions. Look, y'all can tell I miss being in math class, just in case anyone cares. This says if a b belongs to f of x, this implies ba belongs to the inverse. I'm going to actually write the words for y'all, but I like doing that. Okay, so when you're graphing, our f of x is an exponential function, right? So f of x equals b, and it's raised to the x power, has inverse. And this is the same notation we learned before. You do f, it's of -1 of x, that's the inverse. And the inverse of our exponential function, this is what we learned in the last class, is log base b of x, right? That's what I said, that they're inverses. I also said that logarithmic functions, they're 1 to 1, and they have an inverse. These are inverses of each other, right? 1 to 1 is what I'm fixing to describe right here. So what this means is if, and this is a coordinated point, right? If I'm graphing something, I need these points. So if the point A, comma B belongs to this exponential function, right, f of x, say I had something and I actually made a table and I plugged a few values in, and you know what I mean, I've got my x's and I've got my y's. Those a comma b's, they belong to this f of x. If a comma b belong to f and x, then this implies, fancy way of saying this means, right, that, and then the point b comma a, right? They're inverses of each other. So whatever I graph right here for my f of x, all of these points, if I flip the coordinates, I've now, say it did this, right? I've now graphed its inverse, right? So doing this is them being one-to-one. And there's like a line of symmetry that goes y equals x. It's like goes through the origin, okay? Okay, so this implies that the b comma a belongs to, and this is just saying the inverse. Both of those two sentences said the exact same thing, okay? This is saying that they're inverses because this happens, and then this is saying that they're just inverses, like it's just stating a fact. Okay, so if I'm told that I need to graph f of x equals log base 2 of x, my buttons, I have the natural log button, right? That was base E. I have the common log, that was base 10. I don't have a log base 2 button on here. I don't have the ability to just go into y equals and type this in and it show me what I'm graphing. Does that make sense? So if I'm told to graph this, there's ways, but I'm telling you right now, it's much easier just to go ahead, find the inverse. The inverse of the logarithmic function is an exponential function. These are going to be much easier to graph. Once you know the graph of this, like I said, it basically reflects about the x-axis, and then there's your logarithmic function. Now, if it tells you to apply transformations, whenever you actually know what your f of x is, so you know how to graph the inverse, if it says it shifts 5 times to the right, so that would be a -5, right? You would go to that little table on your graph and you actually move it where it needs to be. Okay, so if it tells us to graph this, like I said, we need to find the inverse. This is how I started 4.1. I was introducing the exponential functions. We tried to find the inverse, and then I got to a point where I was like, we can't do this without a log, right? Now that I know these are inverses, I can find each other's inverses. So I'm going to go ahead and I'm going to write this down right here because this is what I'm finding. The inverse of f of x equals log base 2 of x. That f of x needs to be changed to a y, right? Because those are equivalent. Now I'm actually finding the inverse. The way you find the inverse is to switch and solve. Switch your x's to your y's and your y's to your x's. So this y becomes an x equals log base 2 of, now that x becomes a y. So when you look here, you're just like, okay, I don't really know even honestly what I'm looking at, right? You've gotten to a point now where we're going to use the fact that exponential functions are the inverse of logarithmic functions. I'm going to use this form and turn it into an exponential function. So do you remember that form for a log was log? This is the base. This is your exponent, and this was your answer, right? That's just that normal form that we learned last time. I'm just writing it here to hopefully clear up any confusion as to why I'm fixing to do what I'm fixing to do, okay? I get here, I'm trying to solve for the inverse. I know that the exponential function is the inverse. I know this is the general logarithmic form. Now I'm going to write the inverse, which would be b to the x equals a, right? That's the inverse. So b here is 2, and then to the x, my x is x. So 2 to the x equals, what I'm doing is that exponential form, right? B to the x equals a. Here my a is y. Now, change that y to the actual inverse, which is 2 to the x equals f to the negative 1 of x. So now what I'm saying is I just found the inverse of f of x, and the inverse of log base 2 of x is just 2 to the x. And then graphing these, all you really need to know is that, I already have it right here. All we need to know are those properties I told you last time. This is an exponential form, right? And the properties of the exponential functions was that it had the horizontal asymptote at y equals 0, right? So that just tells me I can't touch 0, and that it crossed at 0, 1, right? And it just did this. Don't really have to plot points, or I just need to know for a fact that this exponential function is going to do this. Now, if a comma b belongs to f of x, then b comma a belongs to the inverse. All that says is whatever point you have for either of these functions, you just take the opposite point, and that's the other function. So this one, what I just graphed was the inverse, right? So if I graph the actual function, instead of 0, 1, I do 1, 0. So that's going to be right here. This would be 1, 0. I may have just gotten to where I need to write. It's gonna, because of what we were given, this one on the bottom is our f of x, which is the logarithmic function being graphed, and then that one's the inverse. If you notice, the main point I really only needed was the fact that my exponential function crosses at 0, 1. Okay, that's the main thing. If asked to find an inverse, that's how you go about it. But all I needed to know is that it's easier to graph this because I know 0, 1, and then because they're inverses and they're 1 to 1, that means all I have to do is just a reflection and switch the points. Then you have this graph. This is where in the homework, after you graph this one, because that's the logarithmic one, if it tells you to transform it, then you would just scoot it whichever way it tells you to, okay? I just wrote in asterisks, can apply transformations. And it may ask for like the domain and the range. If we're looking at this one, which is the logarithmic function, the domain here would be 0 to positive infinity, because the domain are my x's, right? And doing this, this will get closer and closer and closer to 0, but it'll never touch 0. My range would be all real numbers. That's because my range covers my y's. This is forever going down. And this, because it's exponential, it kind of continues to go up, even if it, you know what I mean? Just, it's going to eventually end up covering the whole range right here. A little bit easier on the homework, I think, than with a marker. Draw random points. Okay, so let's evaluate these few. One, I did do 2 evaluating without a calculator, and then 2 solve for x, and then you have your quiz. Okay, y'all? I didn't hear you. Yes. I said all real numbers. In my head, all I said was all real numbers, and I was writing the infinities. So I messed that up. Yeah, infinity to infinity is wrong in every math class, no matter what you do, especially in this one. I would probably add it and be like, what is that? But that's all real numbers. An exponential function is going to cross at 0, 1. Now, the only thing is, whenever I reflect this on my homework, I know this. The one I'm graphing exactly is this one. And then I need to look if there's any kind of transformations, that's kind of where you apply them. Okay. Okay. And yeah, sorry. Thanks for that. Because I'd watch this video later and be like, why didn't anybody tell me? I'm so stupid. Okay. Let's evaluate these without a calculator. Okay. I know that there's some problems on the homework that may explicitly state evaluate this without a calculator. I do not expect y'all to be at home with your calculator and me not there and not use your calculator, right? But just know that y'all know how to evaluate these without a calculator because, I mean, obviously in this class, that's going to be what matters the most is solving the problems, okay? So for this one right here, what I have is log and 10. This is what it tells me to evaluate without calculator. So I know that right here, you know, even if it doesn't have an equal sign, if it just says log 10, like I think on the quiz, I don't put an equal sign. This is what you're evaluating is this. So of course it's going to equal something, right? Without a calculator, this is already in like this common log form. And I know that the base is 10. So I would, Okay, so what I would do is I'm going to change this into exponential form. Logarithmic form is like this. The base is base, and then this answer is actually your exponent, and then this is your answer. So it goes base, exponent, answer. So my base is 10. My exponent, right? The exponent is always the answer to a logarithmic one. That's how I know this is my exponent. My exponent is what I'm trying to find. Equals, in logarithmic form, this is my A. So this is my answer in exponential form. Why did I almost said A? Because I said this is my A. That's just an ugly 10. Okay, sorry, y'all. Okay, that's a very ugly 10. So this is saying, because I know that's an implied 10, right? This is saying 10 raised to what power equals 10? It's just 1. You just need to know how to do this form, because if you just do 1, very likely you're going to get very few points. And like, no one wants that. Okay, for this one, and y'all have already switched. I'm done doing cursive. Okay, that's natural log. LN. Natural log E cubed. That's not a base E, that's just the actual E. And so, of course, I'm finding this by hand. I was taught that if I have a natural log, the way I solve this by hand is to take the log base E and then of what you're taking the natural log of. So you wouldn't write natural log in my log, right? I'm just going to write the E cubed right here. And then I notice that property, right? Yes, I've got those 3 things right here. And so my answer is just the exponent, which is 3. Now, if you don't remember the properties, a lot of things could really confuse you for no reason. The properties are very important. Even if you just remember the form, right? It's like, oh, I kind of remember this form. It was just this little small top number, whatever you got to remember, okay? So the answer would just be 3. And y'all, this is because this is saying in logarithmic form, right? This is my base, my exponent, my answer. In exponential form, base, exponent, answer. Do you agree? E cubed equals E cubed? E cubed is the only thing that can equal E cubed. So that's why what's right here in this little exponential form, like just that exponent, is why that's the answer. Let's do these 2, solve for X, and then you take your quiz. Okay. First problem is log base 3. And then in parentheses, right up top right here, I've got X minus 3 close equals 4. If you open up your calculator and you type log and then you try to do X minus 3 and then you try to hit it, that's just not right. And it's because of this base 3, right? I don't have that here. So some have to be performed by hand. You don't have an option, okay? Okay, so when you do this, what I need to do, the way I learned to solve logarithmic and the way I learned to solve exponential is to use each other, right? So I'm going to use the inverse of a logarithmic function, which is put it into exponential form. Now that's why you have to remember this is log base B of A equals X, right? B is here, X is here, A is here. Exponential form, y'all, is B to the X equals A, right? So my B, that's my base, that's 3. I need to raise it to the x power. The answer in this form, that's my x. So raise that to the 4th power. And then have it equal to a. In logarithmic form, this is my a. I just don't have that form written down, y'all. But this is my a. So, and you don't need parentheses. It's the only thing written there. Some of you write them, it's fine. But I mean, honestly, x minus 3 is the only thing over there. So you could drop them, okay? Y'all literally 3 to the 4th power, if you don't have your calculator in front of you, is 81. Equals x minus 3. You add 3 to each side. I get 84 equals x. That's your answer. This is a very simple version of where we're going. So make sure you understand how to solve this by hand, okay? It's really fun though. Again, with the puzzles, whatever, y'all. Okay, so let's do the second problem. Say we have log base 3, and then in parentheses, I have log base 4 of 4, close your, like I said, close your log, close, open and close. Okay, does anybody remember the property? If you have log base b of b, this would be saying b raised to the what power equals b, right? So all of this, again, property is like so important. All of that just became 1. So I'm gonna rewrite this right now. Log, can y'all see me? Base 3 of 1. After a while, there's that other property that I'm hoping you see here, but if you don't see it, that's fine. Put it in exponential form and you can solve it. But y'all, what this is saying is 3 raised to the what power equals 1? 0, right? So you just get 0. If you don't see that, go ahead and pull it to the side. Let's just pretend you see this log base 4, 4, right? Okay, I don't know what that is. Just kind of like PEMDAS. I'm going to start with the parentheses, right? I'm going to figure out inside of here. Okay, so this is my base. I don't know my exponent. That's my a. Oh, okay, that's 1. All right, turn that into 1. And then you get here. And you could literally say, okay, 3 is my base. I don't know my exponent. My answer is 1. Oh, okay, that's 0. You see what I'm saying? But after a while, like as far as time and stuff is concerned, and it just being super tedious, like knowing the properties is gonna be a lot better for you. Okay, so just like I said, every class, and I'm honestly, I want to do until exam 3, like for sure, especially with the matrices, is going to have a quiz at the end of it. Get a piece of paper, put your name on it, and then just, if you could put the date on it. I'm trying to separate all the classes with like paper clips and stuff, but just in case. Goodness gracious, let me end this.